Welcome to The Explainer. Today, we're going to dive into some really fascinating research that basically connects the dots between all these different AI models. It's a journey that starts with the human brain and ends with a brand new toolkit for designing AI. So, here's the plan. We're going to start with a really cool idea from human psychology. Then we'll tackle a huge challenge in AI memory. After that, we'll pull back the curtain on a revolutionary new framework that lets us basically build custom AI brains from scratch. Okay, so where do we even begin? Well, not with computers, actually, but with our own minds. Turns out the key to this whole AI breakthrough is hiding in the way we think. I mean, seriously, think about your day so far. You've seen and heard thousands of things, but what do you actually remember? Your brain doesn't give every little thing the same amount of attention, right? It's constantly filtering, prioritizing, and deciding what's actually worth storing. This is what psychologists call attentional bias. And you know what? It's not a bug, it's a feature. It lets us focus on what really matters. And that led some researchers to ask a really powerful question. What if we could build AI with that exact same ability? So this whole idea of giving AI a bias for what to pay attention to, it actually helps solve a really old problem in how we design these systems. For a long time, we've had this trade-off. On one side, you've got transformers. They're amazing learners, fantastic at understanding context, but their memory, what we call the KV cache, it just explodes in size the more you feed them, which takes up a ton of computing power. On the other side, you have recurrent neural networks, or RNNs. They're way more memory efficient, but they often just can't compete on power or remember things for very long. It's always this choice between power and efficiency. But now a new paper has come along and completely flipped this problem on its head. Instead of seeing these as two separate things, it asks a different question. What if they're actually just two different ways of doing the exact same thing? And here's the big idea. We should stop thinking of these models as mysterious black boxes and start seeing them as a type of associative memory. All that really means is that it's a system that learns how to connect things, how to map a key, like a question, to a value, like the right answer. So how does it learn that connection? Well, it all comes down to its internal goal, the thing it's trying to get better at. And the paper brilliantly calls this the model's attentional bias. Now here's the kicker. It turns out that almost all of today's AI models are just using one of two main strategies. They either focus on how similar things are, which is called dot product similarity, or they try to get their predictions as close to perfect as possible, which is called L2 regression. That's it. Pretty much the entire field boiled